let's see what is the problem in a realistic antenna. Okay. So, a realistic antenna is obviously an antenna where the length is finite. Okay. Now, in a finite length antenna, what current distribution will you assume? No idea, right? So, you might assume, for example, take a transmission line. If I give you a transmission line and I keep it open circuited at the end, and if I bend the two ends, that is one very crude form of an antenna. Okay. So, what is the current distribution on a transmission line? Sinusoidal, standing waves, right. So, it is sinusoidal, particularly if it is open circuited at the end. So, at the end of the antenna sort of wires, the current is going to be 0, and depending on whatever length is, I will have some kind of sinusoidal distribution over it. Okay. I mean, that's, yeah, I am like doing a mental experiment to construct an antenna, right. But this is not going to be realistically, once you bend it, it is no longer exactly a transmission line. So, that current distribution will no longer be a sinusoidal distribution. So, actually I do not know the current distribution in a realistic antenna. If I do not know the realistic current distribution, I can no longer use this expression, right. If I do not know J, how can I find out A, the convolution? So, I do not know J. So, this is where CEM comes to our rescue. So, computational electromagnetics helps us to calculate what should the J be given boundary conditions. I get J, then I go back, plug it into this, get A, get H, get E. So, that is where CEM comes to the rescue, right. So, CEM, we calculate J. Yes, like our very initial example in the integral equation methods, where we wanted to find out the charge distribution, right. So, calculate J, then A, then H and E. That is the general philosophy that we follow, right. Now, there are two different cases that we will talk about. One is transmission, the other is the antenna operating in receiving mode. So, when the antenna is operating in transmitting mode, right. So, this is typically how you will show it. Some generator is over here. Okay. This generator is producing a current, and this current is radiating, this current in turn produces a field. Okay. So, that is the transmitting case. In the receiving case, what happens? If this is my antenna, what is happening? Some E incident is falling on it, on this antenna. What will that E incident do? It will induce a current in this metallic structure, right. So, this is going to induce a current over here, and that current I can take it and drop it across the resistor, calculate the voltage and basically get the signal, right. So, this is what is happening in the receiving case, and this is in the transmitting case over here. So, in both cases, what is common is that there is a induced current, right. In one case, the generator induces a current on the surface of the wire, and then that current radiates. And in the receiving case, incident field comes, excites a current on the surface, and that current which has been excited is what we decode in some sense. So, in both cases, there is an induced current. And for now, we are going to be talking about conductors, in fact, very good conductors. Okay, so just think of a wire. That is a matter of interpretation. You can also think of it as a current that is being induced on the surface, and that current, when there is current flowing through a wire and a resistor there, do you say that the voltage came first and then the current, or current came first and then the voltage? Does not matter, right? It's one and the same thing. Although if you ask a pure physicist, then there are some, from an engineering point of view, it does not matter. Right? There is induced. The reason why we will go with the interpretation of induced current is because we know a way of relating field to current, right. If I know J, I can calculate E, right. So, that is the philosophy that we are going to use. But if you give me voltage, then I suddenly do not know what to do with Maxwell's equations. Where do I put voltage in there? That is electrostatics, right, gradient of electric field or whatever, or gradient of voltage is electric field. Yeah, that's so we follow the induced current philosophy over here. Okay. So, when we continue, we will go more into detail, but the basic point is that we should talk about an induced current. In addition to induced current, is there any other field like quantity here? Yes, in the case of receiving antenna, there is the incident field, right. There is a field that is coming in, inducing a current, that current itself is also going to radiate. Similarly, in the generating case, there is going to be an induced voltage or induced current by the generator and something on the wire. So, there are two things that I have to worry about. Okay. All right.